Imagine you are a logging foreman in northern Maine in the year 1870. You have 4 million board feet of white pine ready to cut. The mill is 14 miles away, down in Bangor, where 3,000 ships sit anchored so tightly together that people say you could walk across their decks from one side of the Penobscot River to the other. Your timber is worth a fortune. But between you and that fortune is a ravine, 100 feet deep, carved out by snowmelt and 10,000 years of runoff, with a river at the bottom that sounds like a freight train when the spring thaw hits. You have no engineers, no cement, no iron beams. You do not have money for steel, even if someone could get it to you, which they cannot, because the nearest rail depot is 40 miles south and the roads are frozen mud. What you do have is 80 men, most of them French-Canadian, a few from Aroostook County, all of them paid $1.25 a day. You have oxen. You have axes, a few cross-cut saws, a dozen hand augers, and a barrel of iron drift pins that weighs more than any single man in your crew. And you have the trees standing right next to the ravine. So you do what logging foremen had been doing for half a century in these woods. You cut the bridge out of the forest itself. 6 weeks later, ox teams are pulling logs across a 100-foot span made entirely of timber. Your men felled, peeled, shaped, and pinned together with their own hands. The bridge will stand for 1 season, maybe 2 if the winter is kind. After the cut is finished and the last load crosses, the rains and the frost will take it back. The forest will grow over the abutments. The iron pins will rust into nothing, and almost nobody will ever know it was there. I have been reading the camp logs and surveyor's notes from a dozen of these operations across Maine, Wisconsin, and the Pacific Northwest. What I found is that the men who built these bridges treated the work as routine. They did not think of themselves as engineers. They were loggers who happened to need a bridge, so they built one. And the bridges they built were, by any honest measure, extraordinary. This is how America built 100-foot logging bridges, and this is why almost none of them survived. To understand why these bridges existed, you need to understand what was happening to the American timber supply in 1870. The country was building. It was building at a speed that has no real comparison in human history. After the Civil War, cities like Chicago, Boston, and New York were expanding by thousands of people every single month. Every house needed framing lumber, every barn needed beams, every ship in the merchant fleet needed masts and planking. Every mile of railroad needed ties. And by 1870, the railroad network was adding nearly 7,000 miles of new track per year. Each mile required roughly 2,500 ties. That is 17.5 million railroad ties in a single year, and every one of them came from a tree that somebody had to cut down, haul out of the woods, and get to a mill. And that demand was accelerating. The Great Chicago Fire of 1871 burned 3.5 square miles of the city to the ground. 17,000 buildings gone in 2 days. The rebuilding effort alone consumed more lumber than some states produced in a year. And Chicago was just one city. San Francisco, St. Louis, Denver, Kansas City, every one of them was growing, and every one of them was built, at its core, out of wood. The nation's appetite for timber was bottomless, and the men who fed that appetite were cutting deeper into the wilderness every season. Maine alone shipped over 8.7 billion board feet of lumber through the port of Bangor between 1832 and 1888. That is not a misprint. Billion. The Penobscot River was the highway. Every spring, after the ice broke, millions of logs went into the water and floated downstream to the sawmills clustered around Bangor, Orono, Old Town, Milford, and Bradley. The Penobscot Log Driving Company coordinated the drives, charging each operator a fee per 1,000 board feet to sort and deliver their timber through the booms. But here's the problem that nobody talks about when they romanticize the old log drives. The rivers only ran one direction, and the timber did not always grow next to the rivers. By the 1860s and 1870s, the easily accessible white pine along the major waterways had already been cut. Logging operations were pushing deeper into the interior, up into the headwaters of the Penobscot, into the remote townships north of Patton, and into terrain that was not flat, not friendly, and not anywhere near a navigable stream. The land in northern Maine, in northern Wisconsin, in the upper peninsula of Michigan, and later in the Pacific Northwest, was cut through with ravines, gorges, stream beds, and seasonal washouts. These were not gentle valleys. Some of them were 100 feet deep. Some were 200. The walls were steep, the bottoms were rocky or swamped, and there was no way to get a loaded ox sled or a logging railroad across them without building something. That something was a bridge. And because steel and stone cost money that logging companies did not want to spend on temporary infrastructure, the bridges were made of wood, cut on site, built by hand. Designed by foremen who had learned the trade from other foremen who had learned it from the generation before them. No blueprints, no textbooks. Just accumulated knowledge passed down through decades of trial, error, and the occasional catastrophic failure. Now, let me tell you what kinds of bridges these men actually built. Because the word bridge covers a lot of ground, and not all logging bridges were the same. The simplest type was the corduroy bridge, which was barely a bridge at all. You felled trees, laid them side by side across a wet spot or a shallow creek, packed them with brush and mud, and drove your ox teams over them. Corduroy roads and bridges were everywhere in the logging country. They were crude, they were bumpy, and they worked well enough for flat ground and shallow crossings. But you cannot corduroy a 100-foot ravine. For deeper crossings, loggers built crib bridges. A crib was essentially a hollow box made of logs, stacked in alternating layers like Lincoln logs, then filled with rocks and earth to give it weight and stability. You built cribs on both sides of the crossing, and sometimes in the middle if the span was too long, and then laid stringers across the tops of the cribs to carry the road surface. Crib bridges could handle significant depth. Some of them rose 50 or 60 feet, but they required enormous amounts of timber and fill material, and building them at the bottom of a ravine was dangerous, slow work. Every rock that went into a crib had to be carried or sledded down to the bottom of the gorge. In winter, when the ground was frozen, moving fill material was slightly easier because you could slide it down on improvised chutes. But in fall, before the freeze, men hauled rocks on their backs down slopes that would give a mountain goat pause. More than one man slipped on wet leaves or loose shale and rode a load of stone to the bottom of a ravine. He was not planning to visit that quickly. The third type, and the one that defined the era of logging bridge construction, was the timber trestle. This is the bridge you see in the old photographs, the ones that look like a wall of wood rising out of the forest floor. Trestle bridges used vertical posts, called bents, spaced 12 to 16 feet apart, connected by horizontal caps and diagonal braces. The bents were either driven into the ground with a pile driver, if the soil was soft enough, or built as framed structures resting on mud sills, which were heavy timbers laid flat on the ground to distribute the weight. For the tallest trestles, the framed bents were built in sections called stories, each one 10 to 15 feet high. Workers assembled each story flat on the ground, then raised it into position on top of the previous one, using block and tackle, ox teams, and human muscle. The process was repeated, story by story, until the trestle reached the height needed to span the ravine. Then stringers were laid across the top, planking was spiked down, and the road was open. The Cedar River logging trestle in Washington state stood 203 feet high and stretched 843 feet long. The two Medicine Creek trestle on the Great Northern Railway in Montana reached 214 feet. These were not engineering curiosities. They were working infrastructure, built to carry loaded trains and ox teams, and they were built almost entirely by loggers. But most logging bridges never got photographed. Most of them were not 200 feet high. They were 50 feet, or 70, or 100. They spanned the ravines and stream crossings between the cutting area and the mill or the railroad spur, and they were used for a single season, or maybe two, before the timber in that section was exhausted and the operation moved on. The bridge was left behind. Nobody maintained it. Nobody repaired it. The untreated lumber began to rot within 5 years. The iron pins rusted. The bracing sagged. Within a decade, the bridge was a skeleton. Within 2 decades, it was a pile of moss-covered logs on the forest floor, indistinguishable from deadfall. Let me take you into the construction itself, because this is where the real story lives. The foreman picks the crossing point. He walks the ravine, studies the walls, checks the soil, looks at the timber growing on the slopes. He is not doing calculations on paper. He is reading the land the way a ship captain reads the water. He knows from experience how wide the span needs to be, how many bents will be required, and how deep the posts need to go to hold the weight of a loaded ox sled carrying 4,000 pounds of white pine. The first job is cutting the timber for the bridge itself. The crew selects straight, sound trees, usually spruce or hemlock in Maine, pine or Douglas fir in the west. The trees are felled, limbed, and bucked to length. The logs that will serve as sills, caps, and stringers need to be flattened on the contact faces so they sit tight against each other. This is done with a broadaxe and an adze. If you have never seen an adze in use, picture a tool that looks like a hoe with a razor-sharp blade. The logger stands on top of the log, swings the adze between his feet, and shaves the wood flat in long, curving strokes. A skilled adzman can flatten a log face as smooth as a sawn board. The work is rhythmic and precise, and it is also one of the most dangerous tasks in the camp. A misswing sends the blade into your shin or your foot. There is no doctor within a day's ride. A deep adze wound in 1870 could mean gangrene, amputation, or death. Once the timbers are shaped, the crew begins assembling the bents. For a pile trestle, the pile driver is brought to the edge of the ravine. The pile driver in this era was a simple machine. A heavy iron weight, usually around 1,500 to 2,000 pounds, was raised on a wooden frame using a block and tackle, powered by an ox team or by a crew of men hauling on a rope. The weight was lifted to the top of the frame, released, and dropped onto the head of the timber pile, driving it into the ground. The process was repeated, blow after blow, until the pile was set deep enough to hold. For frame trestle work, the crew built each bent on the ground. Timbers were squared, laid out, and joined using mortise and tenon connections pinned with iron drift pins. The holes for the pins were bored by hand using a ship auger, a T-handled tool with a spiral bit. Boring a single hole through a 12-inch timber took 10 to 15 minutes of hard turning. A single bent might require 20 or 30 pinholes. A bridge with 12 bents needed hundreds. The assembled bents were raised into position using gin poles, which were tall masts rigged with block and tackle. The ox teams provided the pulling power. 6 yoke of oxen, 12 animals, could pull roughly 8 tons. That was enough to raise a framed bent into position, but just barely. The work required coordination between the teamster driving the oxen, the men guiding the bent with ropes, and the crew at the base who had to position the sill and set the bracing before the bent could be released. This is where men died. A bent weighing 2 or 3 tons swinging at the end of a rope is not a forgiving object. If a rope slipped, if an ox stumbled, if the gin pole cracked, the bent came down. And whatever was underneath it did not survive. Camp logs from operations across Maine and Wisconsin record deaths with a plainness that tells you how common they were. A man crushed by a falling timber, a man killed when a bent collapsed during raising, a man who fell from the top of a partially completed trestle into the ravine below. In 1845 alone, more than 80 men died in logging operations in the Ottawa Valley, and that count only covered river driving. Bridge construction deaths were rarely tallied separately. They were folded into the general count of logging casualties, which in some years ran as high as 1 death per 100 workers. If your crew was 80 men, the odds said that by the end of the season, one of them was not coming home. The injuries that did not kill you were sometimes worse than the ones that did. A crushed hand meant you could never swing an axe again, and if you could not swing an axe, you had no trade. A broken leg set badly meant a limp for life. Frostbite took fingers and toes. The closest thing to a hospital was the camp cook's table, where a man with a bone saw and a bottle of whiskey did what he could. If you were lucky, someone in camp had enough experience to set a fracture or stitch a wound. If you were not lucky, you waited for the tote road to be passable and rode out on a sled, hoping you did not bleed out or go septic before you reached a town with a real doctor. The foreman knew the cost. They watched men get carried out of the woods on stretchers made of birch poles and canvas. They wrote the names in the camp log. They sent word to the families. And the next morning they went back to building the bridge, because the season was short and the timber had to move. The men who did this work were not reckless. They were careful in the way that experienced laborers are careful, with an awareness of risk that comes from watching someone else get killed. But the tools were primitive, the timbers were massive, and the terrain was unforgiving. You were building a structure at the edge of a cliff, in winter, on ice-covered ground, using ropes made of hemp that frayed and snapped without warning. There was no safety net, no harness, no hard hat. There was the job, and there was the alternative, which was no job at all. Once the bents were raised and braced, the stringers went on. Stringers were the long horizontal timbers that spanned from bent to bent, carrying the actual road surface. On a pile trestle, the stringers rested on caps, which were horizontal timbers spiked across the tops of the piles. On a framed trestle, the stringers sat on the top tier of each bent. The stringers were pinned in place with drift pins and sometimes secured with iron dogs, which were U-shaped staples driven into the wood. On top of the stringers went the decking. For an ox road, the decking was usually round logs or split timbers laid crosswise, creating a surface that ox hooves and sled runners could grip. For a logging railroad trestle, the decking was sawn planking with rails spiked on top. Either way, the decking had to be solid enough to carry the load without flexing too much, because flex meant movement, and movement meant the joints would work loose over time. The entire process, from the first tree felled for bridge timber to the last plank spiked down, took between 4 and 8 weeks, depending on the size of the crossing, the terrain, and the weather. A crew of 20 to 30 men could build a standard logging bridge in that time, while the rest of the 80-man crew continued cutting and skidding timber in the surrounding forest. The bridge was not the point. The bridge was the obstacle between the point and the profit. Now, let me tell you about the first crossing, because every logger who lived through one remembered it. The bridge is finished. The foreman walks it himself first, checking every joint, every pin, every piece of bracing. He stamps on the decking. He looks underneath. He knows that the first loaded crossing will tell him whether his bridge will hold or whether it will fold up like a house of cards and send 4 tons of oxen and timber into the ravine. The teamster brings the ox team to the approach. A 6-yoke team, 12 animals, each one weighing between 1,500 and 2,000 pounds. Behind them, a logging sled loaded with white pine logs, maybe 4,000 pounds of timber. The total weight crossing the bridge is somewhere around 20,000 pounds, 10 tons. The oxen do not want to go. They can feel the bridge move under their hooves. They can hear it creak. Oxen are not stupid animals. They know when the ground is not solid. The teamster talks to them, low and steady, using the commands they know. G for right, haw for left, come up for forward. He does not rush them. Rushing an ox team on a bridge is how you lose an ox team and a bridge and possibly your own life. The first pair steps onto the decking. The bridge takes the weight. The timbers groan. You can hear the fibers compressing, the joints settling, the bracing taking the load. It is a sound that carries through the cold air like a living thing, and every man on the crew stops what he is doing to watch. The team moves forward. Pair by pair, the oxen cross. The sled runners hit the decking and the entire structure shifts. Just slightly. Just enough to make your stomach drop. But it holds. The wood pops and cracks beneath the runners, not breaking but compressing, settling into its load. You can smell the fresh-cut timber, sharp and resinous, mixing with the cold river air rising from the bottom of the ravine. If you look down between the planks, you can see the ground 100 feet below, and your brain tells you that what you are standing on should not be able to hold this weight. But it does, because the foreman knows his trade, and the men who cut and shaped and pinned these timbers knew theirs. The load reaches the far side. The teamster does not cheer. He does not celebrate. He turns the team around and goes back for the next load. Because there are 4 million board feet to move, and the season is not getting any longer, over the next weeks and months, that bridge carries hundreds of loads. Thousands of tons of timber cross it. The joints tighten under the repeated loading. The mud sills settle deeper into the earth. The bridge becomes part of the landscape, as familiar as the cookhouse or the bunkhouse. The men stop noticing it. It is just the bridge. And then the cut is finished. The last log crosses. The ox teams are let out. The camp is broken down. The cookhouse is emptied. The bunkhouse is stripped. The blacksmith packs his tools. The men walk out along the tote road they walked in on months ago, heading for Bangor or Patton or wherever the next job is. Behind them, the bridge stands empty. Nobody tears it down. Tearing it down would cost money and time, and the logging company has already moved to the next parcel, the next watershed, the next ravine. The bridge is abandoned the way a snake sheds its skin. It served its purpose. It is no longer needed. The first winter, without maintenance, snow loads stress the bracing. In spring, snow melt saturates the mud sills. The untreated hemlock and spruce begin to absorb water. Fungus colonizes the sapwood. By the second year, the decking planks are soft enough to push a thumb into. By the 5th year, the bracing members have lost their structural integrity. By the 10th year, the bents begin to lean. And somewhere between the 10th and 20th year, the bridge collapses. It does not collapse all at once. It sags and lists and leans, and one day a bent gives way, and the section it supports drops into the ravine. Then the next section, robbed of its lateral support, follows. Within a few seasons, what was once a 100-foot bridge is a tangle of rotting logs and rusted iron pins at the bottom of a gorge, slowly being buried by leaves, moss, and new growth. The forest reclaims everything. That is the lesson these bridges teach, if you are paying attention. Between 1850 and 1910, an estimated 8,000 or more logging bridges were built across the United States. Maine, Wisconsin, Michigan, Minnesota, Washington, Oregon. Everywhere the timber industry went, the bridges followed. The Pacific Northwest produced the most spectacular examples: the Cedar River Trestle in Washington state, the massive structures on Vancouver Island, bridges that stood 200 feet above the valley floor, built by men earning $2 a day, using tools that would have been recognizable to a Roman carpenter. Almost none of these bridges survive. The dozen or so tallest timber trestles ever built are all gone. Not one of them remains standing. Most were abandoned when the surrounding timber was exhausted. Some were deliberately burned to recover the iron hardware. A few were replaced with steel structures when the logging railroads became permanent rail lines. But the vast majority simply rotted and fell, and the forest grew back over them as if they had never existed. Today, you can find their remnants if you know where to look. In northern Maine, in the woods north of Patton, which was once one of the most active staging points for logging operations along the upper Penobscot, old-timers will tell you about the bridge sites along the tributaries. The Patton Lumbermen's Museum preserves photographs and tools from this era, and if you talk to the people who maintain it, they will tell you about walking the old logging roads and finding the evidence. You can still find iron pins in the stream beds, rusted to thin shells of metal that crumble when you pick them up. You can find the outlines of mud sills, barely visible under decades of leaf litter, the wood so soft it breaks apart in your hands like wet cardboard. In some places, you can find the depressions where the cribs once stood, shallow, rectangular hollows in the ground filled with rocks that were never natural to that spot. You can find the outlines of mud sills barely visible under decades of leaf litter. In Washington state, along the old logging railroad grades, you can trace the approaches to bridge sites by the slight depression in the ground where the roadbed once ran. But the bridges themselves are gone. The Weyerhaeuser operations in Wisconsin and Minnesota built hundreds of these structures. Frederick Weyerhaeuser organized the Mississippi River Logging Company in 1872, and by the mid-1870s, his syndicate controlled the majority of timber floating down the Chippewa River. His operations employed over 1,500 men during peak season, with 75 steamboats working the river. The logging railroads his companies built pushed deeper and deeper into the interior, and every railroad that crossed a ravine or a stream required a bridge. Most of these railroads were built to be temporary. The tracks were pulled up and relaid at the next site. The bridges were left behind. In Michigan, the Saginaw Valley operations produced similar stories. In Minnesota, the pine forests between the Mississippi and the Canadian border were laced with logging roads and trestle bridges. By 1890, over 23,000 men worked in Wisconsin's logging camps, and another 32,000 worked in the sawmills. Nearly 450 logging camps operated every winter, and the timber they cut was driven downstream to more than 1,000 mills. A quarter of all working people in the state of Wisconsin owed their livelihood to the lumber industry. The amount of pine harvested from the Black River Valley alone, according to the 1,890 census, could have built a boardwalk 9 feet wide and 4 inches thick around the entire circumference of the earth. In Oregon and Washington, where the trees were bigger and the ravines were deeper, the bridges grew taller and more elaborate. The Douglas fir of the Pacific Northwest grew to heights and diameters that dwarfed the white pine of Maine. A single Douglas fir could produce more board feet than a dozen Maine pines. But the terrain was steeper, the ravines were deeper, and the rainfall was relentless. Untreated timber in the Pacific Northwest rotted faster than it did in the cold, dry winters of Maine. A bridge that might last 10 years in Wisconsin could be structurally compromised in 5 years in Washington's Cascade Range. The logging railroads in the Northwest pushed into country that was almost vertical. Some of these lines climbed grades that a mainline railroad would never attempt. The trestles that carried them across the valleys were correspondingly dramatic. Darius Kinsey, the photographer who documented the logging operations of Washington state in the early 1900s, captured images of these structures that are almost impossible to believe. Walls of wood rising from the valley floor, thin as lattice at that height, carrying locomotives loaded with old-growth logs that weighed more than the engines pulling them. But the principle was always the same. You needed to move the timber. The ravine was in the way. You built a bridge from the trees, growing next to the ravine. You used the bridge until the timber was gone. Then you left. If you subscribe to this channel, you already know that this pattern repeats across every story we tell here. The infrastructure that built America was temporary. It was built by men whose names were never recorded, using techniques that were never written down, and it vanished so completely that most people alive today have no idea it ever existed. Let me give you a sense of scale. Bangor, Maine, shipped 8.7 billion board feet of lumber between 1,832 and 1,888. To move that timber from the woods to the river, logging operations built hundreds of bridges, dozens of dams, and thousands of miles of tote roads. In Wisconsin, the lumber industry employed over 23,000 men in logging and another 32,000 in the sawmills by 1890. A quarter of all working people in Wisconsin were employed by the lumber industry. The bridges, roads, and railroads that supported those operations were built, used, and abandoned in a cycle that lasted roughly 40 years before the timber was gone and the industry moved west. By 1900, the white pine was largely exhausted in Maine. The loggers moved to spruce, which was inferior lumber but still valuable for the paper mills that were replacing the sawmills. Between 1,880 and 1,900, some 40 paper mills were built in Maine, most of them along the upper Androscoggin, Kennebec, and Penobscot rivers. Towns like Millinocket and Rumford sprang up almost overnight, built around these mills, creating what people at the time called magic cities. But the old logging infrastructure, the bridges and tote roads and temporary dams that had served the long log sawmill trade, was already obsolete. The pulpwood industry used shorter logs, 4-foot lengths, and the transportation methods changed accordingly. In Wisconsin, the timber stands of the Chippewa were nearly gone. The mill that Weyerhaeuser's syndicate had rebuilt at Chippewa Falls in 1886 was the largest sawmill in the world at the time, but by the turn of the century, it was running out of trees to cut. Weyerhaeuser was already looking west, buying 900,000 acres of timberland in Washington state from James J. Hill of the Great Northern Railway for $6 an acre. It was one of the largest single land purchases in American history. The bridges they left behind in the Midwest were already rotting. The last log drive on the Penobscot River in Maine took place in 1971. Locals gathered to watch, some of them weeping. One former river driver told the Bangor Daily News that it was like burying a part of yourself. The last drive on the Kennebec was in 1976. The era was over, and it had taken the bridges with it long before the final log hit the water. And now I want to tell you something that does not appear in any of the official histories, because it is the kind of thing that only matters to the people who were there. The logging camps had a hierarchy that was as rigid as any military unit. The foreman was the undisputed boss. Below him were the teamsters, the sawyers, the swampers who cleared brush and built roads, the scaler who measured the timber, the cook who fed the crew, and the blacksmith who kept the tools sharp and the iron hardware in repair. The men slept in bunkhouses built of spruce logs chinked with moss and mud, with double-deck bunks that provided less than 20 square feet per man. There were no mattresses. You slept on a bed of hay or straw that you could replace when it got too rank. There were blankets but no sheets. The bunkhouse smelled of wood smoke, sweat, wet wool, and the pine pitch that stained every surface and every piece of clothing. When these men built a bridge, they did it in the context of this life. They woke before dawn, usually around 4:30 in the morning, to the sound of the cook banging on a tin pan or blowing a horn. The temperature inside the bunkhouse might be 10 degrees above zero if the night crew had kept the fire going. Outside, it was often 20 or 30 below. You pulled on boots that were still damp from yesterday because nothing ever fully dried in a logging camp in January. You laced them tight because a loose boot on an icy log was a fast way to lose your balance and your life. They ate breakfast in the cookhouse, where the cook and his 2 or 3 assistants, called cookies, had been working since 3 in the morning. The cook was second in authority only to the foreman, and a good cook could make or break a camp. Breakfast for an 80-man camp might be 400 pancakes, salt pork, beans, biscuits, molasses, and coffee, strong enough to dissolve a nail. The meals were silent. That was the rule in most camps. You sat at your assigned seat, you ate, and you did not talk. Talking slowed down the eating, and these men needed 5,000 calories a day to sustain the physical output the work demanded. Then they walked to the work site, in the dark, through snow that might be 3 feet deep, in temperatures that could drop to 30 below. They worked until the light failed. Then they walked back to camp, ate supper, hung their wet clothes near the stove, and collapsed into their bunks. 6 days a week. For months. At $1.25 a day. And somewhere in that routine, they built bridges that spanned 100-foot ravines. They did it without blueprints, without safety equipment, without any of the protections that modern construction workers take for granted. They did it because the timber had to move, and this was the only way to move it. I think about that sometimes. I think about what it means that an entire nation was built on infrastructure that was designed to be temporary. The bridges, the logging roads, the river dams, the camps themselves. All of it was meant to last only as long as the timber lasted. When the trees were gone, everything else went with them. The towns went too. Across northern Maine, Wisconsin, Michigan, and Minnesota, logging created towns that boomed and then vanished. Some of them had post offices, schools, even bowling alleys. Most of them were ghost towns within 20 years of the last log being cut. Today, their names survive only on old survey maps and in the memories of a few old foresters. You can walk through some of these sites and still find stove grates, broken sled irons, and boot soles half buried in the forest floor. The bridges were the first things to disappear because they were the most exposed to the elements and the most structurally vulnerable to decay. A log building can stand for 50 years or more if the roof holds. A bridge, open to rain and snow and wind, with no foundation deeper than a few feet of driven piles, starts dying the day the last load crosses it. Between 1,870 and 1,910, at the peak of American logging, an estimated 8,000 or more of these bridges were built. I have seen estimates that go higher, but the honest answer is that nobody knows the exact number because nobody was counting. The bridges were not considered notable. They were not considered engineering achievements. They were considered tools, no different from an axe or a crosscut saw. You used them, and when you were done, you moved on. What I find remarkable is not that these bridges were built. What I find remarkable is how quickly they were forgotten. Within a single generation, the men who built them were dead or retired. The companies that paid for them had moved to the Pacific coast, and the forest had grown back so completely that you could walk within 10 feet of a bridge site and never know it was there. The forest gave the timber. The men gave the labor. The bridges carried the timber out of the forest and into the hands of a nation that was building itself at a speed the world had never seen. And then the forest took the bridges back, log by log, pin by pin, bent by bent, until there was nothing left but rust stains in the creek beds and the faintest depression in the ground where the approach road used to be. If you are watching this channel, you know why that matters. It matters because the things we build tell us who we are, and the things we let disappear tell us who we have forgotten. 8,000 bridges, 80 men per camp, $1.25 a day, and not a single monument to mark where any of them stood. The camps had their own blacksmiths who forged the iron drift pins, the dogs, the spikes, and the hardware that held every bridge together. Good blacksmith could turn out 50 drift pins a day, each one hand-forged from bar stock, heated in a charcoal forge, hammered on an anvil, and quenched in a barrel of water. That hiss of hot iron meeting cold water was one of the constant sounds of a logging camp, as steady and predictable as the ring of axes in the timber. When the camp moved on, the blacksmith packed his tools and his anvil and went with it. The pins he had forged stayed behind, driven into the timbers of a bridge that no one would ever maintain, slowly oxidizing in the rain and snow until they were nothing but orange streaks in the grain of rotting wood. If you found this worth your time, subscribe. There are more stories like this one. Stories about the men and the machines and the infrastructure that built this country and then vanished so completely that it takes a dedicated search through old camp logs and faded photographs to prove they ever existed at all. The forest remembers. Even if we do not.